So this lesson we're going to look at common denominators. So common denominators are needed in order to add and subtract fractions, mixed numbers, improper fractions, so on. First thing we're going to look at is writing fractions based on models. So we can see that common denominators relate to different size pieces in like a pie or like a puzzle sort of thing. So as long as the amount of pieces are shaded are the same, so for instance this one and this one, as long as the pieces that are shaded are the same size, the same amount of the full circle, then we can relate these two fractions as being equal, or we can say that, you know what, we can actually, instead of writing it as a fraction over, in this case, 1, 2, 3, 4, 5, 6, we can write it as a fraction over 4. So write fractions for each set of models. So for this one here, I'm going to look at the amount of shaded triangles. That's 1, 2, 3, out of a total of, I said 6, right? So 3 out of 6. That is a fraction 3/6. If I look at this one, 2 are shaded out of a total of 4. And of course, those two fractions are equal. And we could reduce both of these down to 1/2. They're both equal to 1/2. So both those fractions are the same. So you could say 1/2, you could say 3/6, you could say 2/4. Those are all equivalent fractions. So looking at equivalent fractions, they're the same. We can relate them though with different denominators. So this one, I have 1/3. And this one over here, I have 1, 2, 3, 4 out of 5, 6, 7, 8, 9, 10, 12. Okay, those of course are equal again. So again, 1/3, same as 4/12, and you'll start to see a bit of a pattern here. Like especially this one's a little easier to see because I have a 1 in the numerator of this fraction. Remember, the numerator is the top, the denominator is the bottom. You really have to be comfortable with those terms. And if you look at the 1 on the top of this one to the 4, what happened here? Well, you could say I multiplied that by 4, and also the bottom I also multiplied by 4. So as long as you multiply the top and the bottom, the numerator and the denominator of a fraction by the same value, you're going to end up with an equivalent fraction. And this demonstrates exactly how. All you're doing is you're taking that pie, that circle, and you're cutting it into smaller and smaller pieces, but you're shading the same amount. Or you're shading the same amount of space. You have to shade more of them to equal the same amount of space though, correct? Excellent. Okay, so that's a good demonstration for that. This one over here, I have 1, 2, 3, 4, 5 out of 10. And this again is 2/4. Again, this is another way of writing a half. Those are equal. So we can write 1/2 an infinite number of ways. 1/2, 2/4, 3/6, 5/10, 6/12, anything that is going to be that same ratio, right? This one's a bit more difficult to see how I would have multiplied that to get 5/10, but if I had a half to 5/10 and comparing those two, you could say, you know what, for the top, I multiply that by 5, and for the bottom, I also multiply by 5. So again, as long as you multiply the numerator and the denominator by the same amount, you're going to get an equivalent fraction. These are all equivalent fractions. Okay, so you can write fractions that are equivalent, that are the same value, even if they're under a different denominator and numerator. Okay, so now using that same concept, we're going to find the missing value in each pair. And hopefully this makes sense. So for the first one here, I'm going to use the same method I just looked at above. I'm going to look at the pair that I have. The denominators in this case are, I have them both. So I can compare those two things and I can say, what did I multiply by or divide by? What did I multiply or divide by to get to that next value? So starting at a 4 to get to 8, of course, I multiply by 2. So like we saw above, I have to also multiply the top by 2 to get 6. So 3/4 is the same as 6 out of 8. The second example here, the 5 to the 20, you can look at it either way. Either I could say, what did I multiply the 5 by? Or what did I divide the 20 by to get to 5? So I can divide that one by 4, divide the 20 by 4. And I can also take the 12 and divide it by 4 to get 3. Okay. Or if you did it the other way, you would say, oh, I multiplied the 5 by 4 to get to 20. then you would say, what would I multiply by 4 to get 12? And you could say, oh, 3 multiplied by 4. Either way is fine. This one, 6 to 24. Of course, that's multiplied by 4. Again, you would look at the bottom of this one and say, what would I multiply by 4? Or what would I divide by 4 to get to this one? And that would be 9. So you're either going to ask, what do I multiply? Or going the other direction, which is probably the better way to start with the value that you know. If you're going to go with the other way, I'm going to take this value and I'm going to say, you know what? I divided by 4 to get that value. Divided by, oh, 1 second. Sometimes my pen messes up a little bit and then starts writing before I even touch the screen, which is really annoying. Okay, let's see if that, there we go. Okay, so divided by, no, that did not fix it. Okay, finally got it fixed. So, again, just to reiterate, divide by 4 and divide by 4 to get to 9. So 6/9 is the same as 24 over 36. And we can actually reduce that even further, right? We could say 6/9 is actually equal to 1/3. Dividing both by 3. Sorry, 2/3. Oh my goodness. 2/3. Okay, the last one here. 3 is equal to 12 over what? Now, 3 is a whole number. It's not even as a fraction, but we can create a fraction from a whole number by putting it over 1. We can always do that. If you have a whole number, you can put it over 1, then you can make an equivalent fraction. Then you can add and subtract as a fraction. This is how you add and subtract fractions with whole numbers. So the top, of course, I multiply that one by 4. The bottom, I multiply that one by 4. There's a lot of 4s in this one. So 1 times 4 is, of course, 4. So 3 over 1 is the same as 12 over 4. The main idea is multiplying the top and the bottom by the same amount to get a different fraction. But you have to multiply the top and the bottom, as we saw at the beginning, to get equivalent fractions. Okay, now we're going to look at common denominators. We're going to look at which fraction is greater and how we can compare these things by getting the same denominator. Okay? So one way to kind of do this is to look at multiples of the denominator. So the first one is 3, part A here. The first one is the denominator is 3. So I look at multiples of 3. So I have 3, of course. The next one would be 6. The next one would be 9. The next one would be 12. I'm going to stop there. 4 for the next fraction. So I had 4. Next multiple up is 8. The next one is 12. So I have 12 is a common denominator, a common multiple. So denominators you have to usually sometimes you have to multiply them. Sometimes you would divide too to make it even, to make them the same. But in this case, we're just multiplying them. So we look at 12 as the common denominator. So I have 1/3 is equal to what over 12, and I have 1/4 is equal to what over 12. So we're going to change both of these fractions over 12 so that we can compare them. When they're out of a different denominator, it's very hard to compare them. We don't know how many pieces are shaded out of a total. But if we have the same denominator, it's very easy to say, oh, that one has more shaded than that one out of 12. So this one, the 3 to the 12, I multiply by 4. So the top I multiply by 4. So 1 times 4, of course, is 4. The bottom, 4 to 12, I multiply by 3. So the top I multiply by 3. So I get 3. So we can say which fraction is greater? This one is greater, or 1/3. So put a square around 1/3. Okay, let's look at another example. So I have 2/7 and 1/2. I mean, you could probably tell right away 2/7 is smaller because 2 out of 7 is not even close to a half of 7. But let's just compare them. So multiples of 7 are 7, 14. I'm going to stop there because I know that 2 will eventually get to 14. So multiples of 2 are 2, 4, 6, 8, 10, 12, 14. So just adding by 2. So 14 is my common denominator. So I have 2 out of 7 is equal to what over 14? And 1 over 2 is equal to what out of 14? So for this one, 7 times 2. So we multiply by 2. So we're going to multiply the top by 2 as well. And I get 4. This one, 2 to 14, I multiply by 7. So I'm going to multiply the top by 7 as well. And I get 7 out of 14. So I can see right away that 1/2 is greater. 7 out of 14 is bigger or greater than 4 out of 14. Okay, a couple more examples here, just to make it really, really clear. So 3/5 and 2/3. So you could write out multiples of each one. Here's a trick though. Sometimes it's easy just to multiply these two together. 5 times 3. And 5 times 3 is 15. That will get you a common denominator right away. It may not be the lowest common denominator, but it will help you get a denominator right away. And I know that is the lowest one because 5 and 3 are both prime numbers. So if I was to write out the multiples of them, the only ones that would work are 5 times 3. So 15. 3 over 5 equals what over 15? And 2/3 equals what over 15? So the bottom is multiplied by 3. The top, we're going to multiply by 3. So we get 9. The bottom of this one is multiplied by 5. The top of this one, we're going to multiply by 5, so I get 10. These ones are very close. 9 out of 15 and 10 out of 15. So we know that 10 out of 15 is bigger, so 2/3 is bigger than 3/5. The last example here, 3/4 and 1/3. Again, I'm going to multiply these two denominators together. So I get 12. Then I take 3. I'm going to try to do this a little quicker this time. Put them over 12. Put them over 12. 4 times 3 is 12. So 3 times 3 is 9. Remember, I'm multiplying by the same amount. It's very common to say 4 times 3 is 12, so I'm going to multiply 3 times 4. But no, you're multiplying by the same amount at the top and the bottom. 3 times 4 is 12, so I'm multiplying by 4. 1 times 4 is 4. So I can see right away that 9/12 is bigger, which means 3/4 is bigger. Okay, moving on. Conclusion. We find the lowest common multiple, or you can multiply them together because often that will, well, not often, but sometimes that will be the lowest common denominator, as in the last part, C and D. But it is usually best to find the lowest common multiple. Otherwise, what you're going to have to do for the final answer is you're going to have to simplify it. But to compare two fractions, it's totally fine. It doesn't have to be the lowest common, because as long as it's common, as long as the denominators are the same. And then you multiply the numerator and the denominator by that same value to get equivalent fractions, to check to see if they're the same, which one's bigger. Again, as we saw in the very first example, how many pieces are shaded out of a total, so we can compare them, so we can see. So hopefully that helps you with common denominators and how to solve for common denominators, how to compare fractions. Yeah, in the next lesson we'll look at adding and subtracting.